Welcome to the SEI podcast series, a production of Carnegie Mellon University's Software Engineering Institute. The SEI is a federally funded research and development center operated by Carnegie Mellon University and funded by the U.S. Department of Defense. Today's podcast will be available on the SEI website at www.sei.cmu.edu/podcast. My name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I'm very pleased to introduce you once again to my friend Grace Lewis, who's done many kinds of research at the SEI. She has dealt with edge computing, with cloud computing, software architecture, service-oriented architecture, technology evaluation. I could go on. But today we're here to talk about trust, and not trust between people in this normal way, but a technology-based kind of trust. So I'm going to let Grace say a little bit about how she came to this research. Why is this research important to you right now? And then we'll get into talking about it.
Well, thank you, Susie. Well, like you said, I've been dealing with what at the time had been emerging technology. So like cloud computing, service-oriented architecture. I like new stuff. And as I was doing my research, I always felt that the tactical space was really not well served. Maybe it's not where the commercial marketplace is interested, but I always felt that it was not well served. And these people in the field need so much technology and need so much help because they operate in environments that are very difficult. They're impoverished. They don't have access to power. They don't have access to all this great bandwidth. They don't have access to just the normal things you would find back in the data center, right? In addition, there's stuff happening around them. If you look at a first responder, there could be buildings falling.
Sure.
If in the military, well, stuff happens, right? And so I really started to look into this area of research, and that led to what has been probably like our biggest output, which is tactical cloudlets.
Yes.
So tactical cloudlets they're forward deployed, discoverable computing nodes that are placed in proximity of mobile devices.
Okay.
And what mobile devices do is that they discover them, and they're able to use them either to offload computation. So for example, expensive computation doesn't execute on the mobile device, but rather executes on the cloudlet. And also for data staging, meaning the cloudlet could serve as a collection point for data that is being gathered in the field.
Sure.
Or the other way around, it can store data that has either been pre-provisioned in advance to support a mission, or maybe data that is being synced back with the enterprise as it becomes available, as connectivity becomes available. So that's how I got to tactical cloud. It's really trying to serve the people at the tactical edge.
So what's the problem with tactical cloudlets and trust?
So one of the key features of tactical cloudlets, like I said, is that they're discoverable, right? So a mobile device in the field is going to say, are there any cloudlets around me? From a mobile device perspective, I want to make sure that cloudlet is a friendly one. It's a good cloudlet, right? And the other way around, it's also true. If I'm a cloudlet and a mobile device says, I would like to connect to you, I need to know that it's a good one.
So in a first responder situation, one of the unfortunate things that happens is you get looters that follow around the first responders looking for riches.
Correct.
So this is a case where the trustworthiness, a smart looter would discover whatever computing resources to find stuff and do things we don't want to happen.
Correct.
So we want to be able to have some way of preventing that kind of situation from occurring.
Correct. And the same is true in the military.
Right.
Correct.
Okay. All right. So what have you found?
So what we did was a combination of things. So first of all, we created a threat model. Right? We created a threat model to say, what are the biggest threats in this type of environment? And not surprisingly, the biggest threats are node impersonation and capture, exactly what you said. So what we did was, okay, let's try to focus on what would be the extreme scenario. So the extreme scenario is you have a cloudlet that is fully disconnected from the enterprise.
Okay.
Okay, so there's no reach back to the enterprise.
I can't verify your permissions or anything like that.
So let's take the extreme scenario and let's create a solution that will be very generic and not make so many assumptions about things like hardware or whether credentials were pre-provisioned in advance. So what we did was, going back to our 4 requirements, what we did is, okay, let's create a solution that addresses 4 requirements. The first one, like I said before, is I have no connectivity. So I can't rely on going back to the enterprise to do any type of online credential validation or anything like that. The second, no hardware requirements. Because in a lot of these situations, a lot of organizations come together to support a mission, right? So you can't place any requirements on hardware,
okay.
or you shouldn't place any requirements on hardware. So we said no reliance
Only the
on
iPhones over here, only the
no,
Androids over there, right?
correct.
Yeah, you
No
can't do that.
reliance on trusted platform modules, TPM, nothing like that. The third one is because we can't guarantee that cloudlets and mobile devices are going to be deployed at the same time by the same people. We said no credentials pre-provision on mobile devices. So we're going really extreme.
Okay.
And the fourth one was whatever we created had to address the threats that we had developed in the threat model.
Okay.
Right? So after a lot of investigation, looking at different things, looking at, for example, biometrics, behavioral metrics, looking at what people do in mobile ad hoc networks, and we ended up finding a solution that Stanford had created many years ago called identity-based encryption.
Okay.
And it's very useful for these environments because it's very lightweight. It's called IB. Because what it does is it doesn't really rely on certificates and things like that, but rather it says, okay, your identifier, which is basically your public key, is going to be any arbitrary string.
Okay.
So for example, in the context of secure email, which is what they had been using it, your ID or your public key was your email address, which is unique.
Okay.
And so for us, it was great because we could use something, for example, in our case, we just use the Android device ID as the public key.
Okay.
So based on that, it creates it allows for a very lightweight solution where you don't have to do a lot of certificate processing and things like
Right.
that.
There's not a lot going on in the background.
Correct. And the second thing was that in order to address node impersonation and capture, we had to combine that with secure key agreement without a trusted third party. I know it sounds like a
Secure key agreement without a trusted third party. Okay.
So
trust just between the two of us.
without having to rely on an external party.
Okay.
And so basically what that means is using out-of-band channels, like for example, using voice or using physical proximity or using something where we can establish that first encounter, that first channel of trust.
Without the device.
But yeah, and then we get
Okay,
into this. So we develop what we call a four-step solution. So in the first part of the solution, which we call it the bootstrapping phase. So in the bootstrapping phase, basically the cloudlet sets itself up as a key generation center.
Okay.
Meaning that it's going to generate credentials for itself and for any device that wants to connect to it.
Okay.
The other thing that happens during the bootstrapping phase is that mission duration is set. And that will become clearer when I talk about credential revocation, which basically means this cloud is going to be available for the duration of this mission, which we're going to decide now it's 3 hours.
And after that, everything we've done is now void.
That's what's going to happen at the end. So great.
Okay.
So that's the bootstrapping stage. The second stage is what we call device pairing. So basically what would happen is if I have a mobile device and I'm going to go out into the field and do something with this cloudlet, I have to physically come up to the admin of the cloudlet and say, I would like to pair this device with your cloudlet. After a visual confirmation, which would be the out-of-band channel, and physical proximity, because we implemented it for Bluetooth and USB, what happens is that the cloudlet generates credentials for this device based on the device ID, which means they're only valid for that device.
Right, right.
And sends me those credentials.
All right.
Why? Because we established a secure channel based on visual confirmation. So that's device pairing. So now I go out into the field, and I want to use the cloudlet. So the third step is Wi-Fi authentication, which means once I have my device and it has been paired, and a cloudlet says, I'm here, I'm here, and I do Wi-Fi authentication. Why? Because I want to know that the cloud is good. The cloud wants to know that I'm good.
Right.
So because we've already exchanged credentials, we can do that very easily.
Okay.
So we use something called Radius, which is a pretty well-known Wi-Fi authentication protocol to do that. And once that is done, step 4, API request. Now the mobile device can start interacting with the cloud in a very secure way. Now, in addition to that, because node impersonation and capture are such high priority threats, we have to have a way to revoke credentials. So the first one is, we call it automatic, which is when the mission time expires, when the duration expires.
We're done.
Done. No, that device can no longer use those credentials. And the other one is manual. So for example, if I know that a device has been captured, has been compromised, I can manually go into the cloud and say,
As the admin.
say, I don't want this. No, this device can no longer connect. So that's basically what we did.
Okay. This is fun.
It is fun.
And so what comes next with this research?
Right now we have 2 ongoing threads. The first one is something else that is very important in these types of environments is to be able to share information. We're not talking secure now, but just being able to share information. Share information in environments where you can't guarantee that there's always going to be connectivity between everybody, in not only everybody in the field, but back to the enterprise. So one thing we're working on now, and we're running experiments and it's looking really good, is something called delay-tolerant data sharing. So what we're doing with that is we're taking advantage of something called broadcatching.
Broadcatching, not broadcasting.
Broadcatching.
The opposite of broadcasting, maybe.
Maybe, I don't know.
Yeah.
So basically broadcatching, what it does is it combines BitTorrent, which is a delay-tolerant protocol. It combines it with RSS, which is what people usually use to subscribe to things.
Right.
And so basically it's a solution based on that enables people in the field to say, I have a file, and I'm going to tag this file with whatever tags it is. It uses RSS to make that announcement. And then people, on the other hand, will say, if there is ever any file that is published with this tag, image, map, I want it. So it uses RSS for that. Once RSS is used to do that, then what it does is it uses BitTorrent, which is a delay-tolerant protocol, to get that file, assemble it, and
so the delay tolerance is basically I wait until there is enough connectivity, I wait until there's enough power.
BitTorrent does that.
That's what I'm saying. That's what that does, is
correct.
it gives you that ability to not know if you're going to have connectivity. It takes care of that for you in the middle.
BitTorrent is great,
Very
and
nice.
the results are really good. And the other thing that we're doing is we are recognizing, and people are recognizing, I mean, Internet of Things. It's here, and there's a lot going on. So we're extending that concept of cloudlets, where we've always thought of cloudlets as there's the enterprise, there's the cloudlet as an intermediary layer, and there's devices. Well, there's another fourth layer out here, which are sensors and actuators, IoT. So how do you incorporate those IoT elements into this whole system? Considering that IoT devices are even more constrained. I mean, some of them don't even have a user interface.
And some of them don't have any security either.
Don't have any security, don't have a user interface, don't have a lot of processing power.
Even less, yeah, because our phones, which is the most common peripheral device today, actually has huge amount of processing.
So we're starting to work in that
But sensors are a lot more diminished, more impoverished.
Yes,
I guess
they
that's
are.
my word of the day.
Yes, it is.
So,
Yes, they are.
Excellent, excellent stuff. So transition. What are some of the transition activities? Since that's something that we worry about at the SEI, is not just doing good research, but actually getting it out to people who need it.
Correct. So in addition to publications, which are available from my website, we've released a Tactical Cloudlets software as open source.
Nice.
Yes, it's available on GitHub, and the address is github.com/SEI-AMS/PyCloud, PYCLUOUD. Yes.
Cloud. Yeah. CLOUD Cloud.
Yes.
Okay, so people can actually experiment with this on their own, and the publications will give them instruction and
No, actually, it's actually very well documented. Believe it or not, it's very well documented. Our software is very well documented. The GitHub repo has a wiki that comes with it, and
good.
all
So
the
you've got
steps
all
are
that.
there. And people are starting to using it, and it's great, the community that forms itself when you have an open source product, because people have told us, oh, found a bug, and it's like. And so
we gotta fix that.
So that work, or people are like, I want to use it this way, I want to use it this other way, and so we've created. I'm not going to say we have tons of followers, but we created a little bit of a following of people that are using it and very interested in what we're doing.
What's the most unusual or unexpected use of this tactical cloudlet idea that's come up as a result of this community?
You know what? The usage, I think it's really.
It's consistent.
It's consistent. I would say it's one of two things. One is kind of like the more traditional, because this Tactical Cloudlets work comes out of cyber foraging, that idea about offloading computation. So one use case is really, I have to do speech recognition. If I do this, or object recognition, if I do this on my mobile phone, I'm going to drain the battery in 2 objects.
Gotcha.
So being able to locate a cloudlet and say, hey, I just took this picture. Can you please recognize this face for me, this object for me? So computation offload in any type of scenario, I mean, that's one use case.
I'm envisioning a new kind of geocaching game.
Of course you are.
That takes advantage of this. I don't know why.
Of course you are. And
all right, gamers out there.
and the other one is more for what I said before, like data staging. So for example, being able to say, I'm going to go out on a mission and I'm going to need I'm going to need maps, I'm going to need this capability, that capability, this software, and being able to just pack everything inside your cloudlet and just kind of like take it with you.
I'm a marathon runner, and I need maps of the area. I need to know where the rest stops are and all the rest of it. I mean, I'm envisioning some other edge cases.
Yeah, but another not that I've done, but another big use of this technology is in healthcare.
Sure. Oh my gosh.
And there are lots of. I mean, there's a wonderful project out there. I don't remember the name right now. Where basically what they're doing with this type of technology is using it for dengue detection.
Dengue fever.
Dengue fever, exactly.
Okay.
Where basically what they do is that they take a blood sample, and they use there's basically these stickers that turn different colors based on what's on the blood composition at the moment. And if you take a picture of that, it can be processed by a cloudlet, and now somebody can tell if a person has dengue in seconds, whether before they used to have to take the samples, go to a lab, who knows how far away.
Yeah.
So I mean, things like that where you can do that can help you do processing, just on the fly are great.
That's going to be. You can be very proud. This is going to be. I think this is going to take. There's going to be a lot of things based on this that nobody even thinks about because they don't have a way of getting that edge power.
Yeah, so definitely healthcare education.
You're going to have to come back and tell us what cool things are happening in the next couple of years.
I'd love to.
I want to thank you as always. Every time I talk to you, it's just the coolest stuff. You do like the emerging technologies. I will verify that.
I do.
And so that's wonderful. Thanks for coming. I know you've got a blog post on this topic.
Yes, I do.
As well as we've got the GitHub. So lots of places people can go to
published a paper
found that.
where all this is described.
Yeah. So this is all good. We will provide links in the podcast to all these kinds of resources that you've provided for us. So everybody will be able to have some fun with this. I might even have some of my own fun.
There you go.
So this podcast, as we all know, will be available on the SEI website at www.sei.cmu.edu/podcast. It will also be available on the SEI YouTube channel and on Carnegie Mellon's iTunes U site. As always, if you have any questions, please don't hesitate to contact us at info@sei.cmu.edu. Thanks for watching.